Okay, let's talk about rotations. I just want to point out a couple of things before we jump to looking at the graphs. On a rotation, we're talking about things when they're turning. Okay, yay. And like a clock, where a clock turns clockwise, for all of our rotations, we're going to talk about turning counterclockwise. So that means sort of rotating to the left, not rotating to the right. And so we're going to go in degrees. Remember, a circle has 360 degrees. Circle equals 360 degrees. So we talk about rotating 90 degrees, 180 degrees, and 270 degrees. So 90 degrees would be a quarter of the way. 180 degrees would be half the way. And 270 degrees would be 3/4 of the way around. And this all depends on where you start. So if we look at the next slide, if we start here in quadrant number 1, this is quadrant 2, 90-degree rotation would be over here. This would be 90 degrees counterclockwise. Down here, quadrant 3 would be a 180-degree counterclockwise rotation. And quadrant 4 would be the 270-degree counterclockwise rotation. So 90 to here, 180 halfway, 270 3/4 of the way, and obviously you wouldn't do a 360-degree rotation because that would just put you right back where you started. So if we look at this, really important on our initial example here to use coordinates, and we'll just use ABC again because that seemed to work the last time. And so if A, maybe I'll write down here, coordinate A is 2, 0, B is 4, 0, and C is 3, 2. And so what do these all become? Well, A, if you can picture rotating this to here, okay, this is A prime. This is B prime. And this is C prime. Okay, so we've just kind of pick it up, slide it over, rotated. Well, 2, 0 has become 0, 2. Okay, well that wasn't too bad. 4, 0 has become 0, 4. And 3, 2 has become negative 2, 3. Negative 2, 3. So here's what it looks like is happening. It looks like we've taken all of these x's here and made them into our y value. So if we just take the generic x, y, it looks like the x's have all become the y. So we're going to put the x in the y position. And it's hard to tell with the zeros, but the y value became negative. So the y is going to become negative. So our rule for 90 degrees, just to rotate it up here, is the x becomes the y becomes the x, but becomes negative, or the opposite. So this was a 90 degrees counterclockwise rotation. Here, hopefully you're saying in your head, well, this one is 180 degrees counterclockwise rotation. Okay, we've just totally flipped it around. So again, do our same points, A, B, C, and again, we're going to write this. A is 2, 0, B is 4, 0, C is 3, 2, and A is now, if you think about rotating this here, A is now negative 2, 0. and B is, so this is A prime, B is negative 4, 0. And C, this is B prime, here's going to be C prime over here, negative 3, negative 2. So it looks like our rule for xy is going to be the x's just become negative, but stay where the x is, right? Positive 2 became negative 2, positive 4 became negative 4. Again, it's hard to tell with the zeros, but it looks like the y here became negative as well. So the x became negative and the y became negative, negative y. So 180 degrees rotation, x and y stay the same, but if it's positive, it becomes negative. That being said, if we were starting over here, if the green one was our original one, and we rotated it over here, the negative would become positive. All right, one more example, 270 degrees counterclockwise rotation. We've come all the way over to here. So again, A, B, and C. Rotate this around. This is A prime, B prime, C prime. So A has gone from 2, 0 to 0, negative 2. B has gone from 4, 0 to 0, negative 4. And C has gone, the most telling one, from 3, 2 to 2, negative 3. So, for our rule, it looks like the y's are becoming the x. See how the 0, 0, 2 here became 0, 0, 2 for x? So it looks like y is going to be first, and the x values, 2, 4, and 3, all became the y values but became negative. Y, negative x. This is sort of the opposite of what the 90-degree rotation was. So if we compare the different rules, x, y for 90-degree rotation becomes negative y, x. 180, see if it's going to let me write in the degree symbol. Okay, look at that. Negative x, negative y. And 270, y, negative x. So what does this mean in terms of the shapes? Well, it means that obviously the coordinates change, which means the position obviously changes. And then the slopes change. Okay, if we look back at this example, two examples, this was a negative slope here, C to B. Here, C to B is a positive slope. So the slopes are changing. Whoops, too far. What's staying the same? Obviously the lengths are the same, and the angles have stayed the same. So it's the same shape, just in a different position. All right, that's it. See you in class.